All right, we're going to take a quick look at what's called the hyperbolic sine or the sinh and the hyperbolic cosine or the cosh x. And we're just going to look at their behavior in terms of increasing, decreasing behavior, and also we're going to look at concavity. So we're going to be looking at their first and second derivatives. Okay. So if I want to take the derivative of the sinh, it's going to be equal to derivative of e to the x is e to the x, and the derivative of e to the minus x will be minus e to the x, but we already have a pre-existing minus in the formula for sinh, so it just becomes plus e to the minus x over 2, and I think we just saw this somewhere. Oh look, we did. It's right there. It's the cosh. So derivative of sinh is cosh, kind of like the derivative of sine is cosine. So we have some sort of cyclical or repeating pattern here. Okay. Now, e to the x looks like that. E to the minus x looks something like that. They have a horizontal asymptote y equals 0, and they intersect only at one point, and it's 0, 1. Okay. And we're just going to look at if it has any increasing, decreasing behavior. What does it have? Well, based off of this, their graphs here, I'm actually taking the average, dividing by 2, which is, take the average of something positive, still positive. So they're both above the x-axis, which means they're both positive. And what that means is the cosh is never equal to 0. And when we're looking for intervals of increasing, decreasing behavior, we're looking for critical numbers. Critical numbers are where you have a horizontal asymptote, where the first derivative is equal to 0, or where we don't have differentiability at a certain point, but it's defined for the function. Well, e to the x is a nice, very nice function. It's differentiable and continuous everywhere. So we don't have any critical numbers. So the cosh of x is never 0, and that's for all x in the real numbers, and it's always positive, which means it's always increasing all the time. All right. Now we're going to look at the second derivative to talk about concavity. So one, we know that the sinh is increasing all the time. We're going to check out the concavity. So the sinh of x is increasing all the time. Now to take the derivative of the sinh, I'm sorry, we're looking at second derivative, so we're going to look at the cosh. So second derivative, take the derivative of the derivative, and derivative of e to the x is e to the x, and then derivative of e to the minus x will be minus e to the minus x all over 2, and we just saw that. That's the sinh. So the pattern's a little bit faster, or a little bit quicker than it is for the regular sine. So we just go sinh, cosh when we're taking derivatives, whereas with regular trig functions, go sine, cosine, minus cosine, sine, cosine, minus cosine, blah, blah, blah. Okay? Now, I mentioned that these two functions only intersect at one point, and that's at 0, 1. So when I take the difference, the only time that's equal to 0 is at 0. Okay, and then I can play the plugging in numbers game. So here's my 0, I'd plug in -1, and I'd plug in 1, and I'd find that I have concave down here, concave up here, and I'm going to have a point of inflection at 0. Okay, so that is our concavity for the sinh. And what it kind of looks like, it looks a little like the cubic function, something along those lines. Point of inflection at 0. Okay, now we're going to take a look at the cosh. So I take the derivative of cosh. Well, the derivative of cosh, we already did that, didn't we? It's right down here, isn't it? Okay, so we said it was negative from negative infinity to 0. So and from 0 to infinity it was positive. Okay, so the derivative of cosh is the sinh, and so instead of talking about concavity, we're going to talk about increasing, decreasing. So it is increasing from 0 to infinity and decreasing from negative infinity to 0. Now the second derivative of cosh would be the derivative of sinh, which would get us right back to cosh. And for cosh, it's always positive, which means if we're looking at the second derivative, then it's concave up all the time. And what the cosh looks like is something like this, kind of like a parabola, and then it has a minimum at 0 and 1. Okay, so just a little quick thing about the sinh and the cosh. Okay.